sort of shift our gears, okay? So what we've been doing for a while now is factoring and solving rational equations. We've been using rational expressions, multiplying, dividing, and all that. Now, we are still talking about rational things, but this unit is rational exponents. And if you remember this word rational, whenever you see that word in math, you're going to be talking about, you remember what rational means? Numbers that look like a certain way. It starts with an S, it's classical appropriate, but not fractions. So fractions. So we'll be talking about exponents that are fractions. Okay? With our new computers and the new software, we keep recalibrating those. Thickness of the line doesn't increase. Okay. First world problem. So give me an example of something with an exponent. X squared, absolutely. Give me an example of something with a radical. Square root of x, absolutely. One thing I want to say about a square root, there's no number written in the root section, right? Exactly. If it's a cube root, you want to write it. If there's a fourth root, you want to write it. Oh, I put 4 there, but I have to put it there. Still thing. The square root really means there's a 2 there, but it's such a common root that we just don't have to write it. There's only your 2. And then an example of something with an exponent and a radical. This is the key to what we're talking about today. If you were to, what? X to the 1/2, that is kind of no radical. Think y'all saying marvelous things, but I can't really understand. But thank you. Something like this. This has an exponent right there is 3, and it has a radical that's a 4th root. What we're going to be talking about today is how to rewrite this with a rational exponent or a fraction exponent. And it's this. What's going on that would make these things the same? Dividing the exponent by the radical. This is the power, right? The 3. And the 4 comes from whatever root you're talking about. And these are equivalent ways of writing. You can go either way, like none of them are the same. So this is the basic idea of what we're talking about today. So and then I had a real quick example of a real world thing that has a rational exponent. So here are the planets in our solar system. And we have this formula called Kepler's 3 laws of planetary motion, which says this, that you can calculate the maximum distance of a planet from the sun just by knowing how long it takes that planet to orbit the sun one time. Who's our astronomy people? Doesn't that mean one day when you orbit the sun one time? Or is that a year? That's a year. It's a year. It's for this, right? And what's going on for one day? That's just the moon rotating. Okay, and that's also 1 year, right? But what is 24 hours in a measure of? I know it's a day.
The Earth's rotation.
Well, that's how we have leap year. Right.
And so, like, that's not being safe.
So, going back to the whole formula. The maximum distance where P is the amount of time in Earth years it takes to go around the sun. One thing I like about these kind of formulas is this. It took probably a whole lot of complicated math and lots of years and some really smart people to come up with that formula. But look how simple it is. It's just 2 variables and an exponent. But it does have a rational exponent, right? So this is what we're talking about today, and it is something that actually gets used in the real world, not just something we're trying to torture people with. Also, this one, Einstein's formula, such a simple thing. There's just three variables. One of them is squared. But it took really smart people with a lot of time. Just a law of relativity. Is this something to do with gravity? I mean, I do sometimes know, but I don't currently know. I do. It's your motto. Okay, so here's the thing. The basic idea, so rewriting rational exponents. So rational means, again, fraction. Here's the basic form for what we're talking about. Write that down. A to the m over n. Which of those things is the base? What we call the base? A. So A is the base. Which of those things is the power or the exponent? And so n, whatever's in the denominator, is the root. So if you were to say square root, that number in the bottom would be 2. And there's two different ways you can rewrite this. So this right here is rational exponent form. Okay? But if you wanted to convert it to a radical expression, there's two different ways you can do that. One is this. You could say a to the m, right? That's the power, the exponent. And then you could rewrite that number in the bottom as a root. You would write your radical sign, and whatever numbers for n goes right here. Right? So if it was 4th root, it would be 4. The second way that you can write this, and it's my preferred way for when we get to this last section on your notes where we're actually simplifying these, is to write the root first, put parentheses around it, and the power on the outside. And I'll explain when this is useful later in the notes, but for right now, it's right now. So here's how the rest of the lesson is going to go. We will practice writing, in this section, I'll give you bases that have fraction exponents, and you're going to rewrite it with radicals. In this section, we're going to do the opposite way. I'm going to give you radicals, and you're going to rewrite it with fractions. And then on this last one, we're going to do that, but actually do the math on this. Okay. Here we're just rewriting. Care about the math. Here we're going to do the math on it. So as we go through these first two, you might be like, oh, this is even hard. I hate it so much. But the reason why we're going to be practicing it anyway is because once we start getting into more complicated material, you'll forget. You'll forget which way it goes. Which one is the top, which one is the root, etc. So the practice is good, even if it's going to kind of kill you. So here's the first example. I'm giving you a base with a rational exponent, and we are going to write it with a radical instead of the exponent. So you're going to write the base. The power goes on it first, and then you write your root sign, your symbol, and the 3 goes with the root. You don't have to write the 1. Optional. What number for the root is optional? 2. So for power of the optional number is 1. For root, the optional number is 2. That you don't have to write it if you don't want to. Because they're so common, we understand that they're there without having to write them. In fact, that's what this example is. So write 8 to the 1/2, how you think you would write it. if you were writing that with everything included, it would look like this. Your base to the power of 1 and the root of 2. In this particular example, though, remember, you don't have to write a power of 1. And you don't have to write a root of 2. So you could also just write this, and it would be fine. Okay? Every other numbers have to be written, but those are the 2 special cases where you could leave it out if you so chose. Try this one. 5 to the 2/3. So you need a 5, you need a radical. What number did you put outside the root? 3. And then you put what for the power? 2. Okay. Last one for this section. What's different about this base? There's a variable. That's not the only thing different. Why do you think there's parentheses here? So we can get the x and the 3. So when there's more than one part to the base, you need the parentheses. Because without the parentheses, if they weren't there, like imagine they were gone, then that 2/5 would be on the x only. So it means something different, completely different with or without the parentheses. So 3x goes inside, parentheses, squared. So even inside the radical, you still need them. And then 5 for the root. Is root of 3x quantity squared. So this was converting rational exponents to radicals. Now we're going to go the other way. I'm going to give you radicals. You're going to rewrite it as a base with a rational exponent. So I'm just going to write them all down and you do them, and then I'll ask a few of you to come show what you're doing. The 7th root of x cubed. The square root of 9. The 5th root of 4n. And the 3rd root of 6x over 7 squared. Talk about how there's 2 parts going on here, okay? You are taking a power of a number, and you're taking the root of a number. Which one makes the number bigger, the power or the root? Power, right? And depending on your base, that number could get big really, really fast. Like if you had 120, and you were going to square it, that's a really big number. So the fact that we're doing 2 different maths on it, if you did the power first, it would get really big. But then you would have to do the root. That would be hard. So we're going to start with the root because it makes your number smaller to begin with before you then do the power and make it bigger. That's a lot of words, but here's what I want you to write down. I'm not going to give you numbers that are so big that you can't just use your baby calculator. So you want to do so write this down on the side somewhere. Do root first. Do power second. Because that fraction exponent means you're doing 2 different pieces of math, of power and root. Doing the root first makes it small, so then when you go to do the power, it will be very hard. It'll be less difficult. So here's our first example. 125 to the 2/3. I want us to rewrite this in radical form first, using the second way that I showed you up here, where you put the root in parentheses and the power on the outside. So what that looks like for this example is if you're doing the root first, which is the root, the 2 or the 3? So if I write the root first, it looks like this, cube root, and then the power on the outside. So what does the cube root of 125 mean? It means what times itself 3 times would give you 125. What do you think? 5. And here's why. 5 times 5 is 25. Times another 5 is 125. That's what third root means. The most common mistake here is you think you're supposed to do 125 divided by 3. And it's a different concept. The answer is 5 inside the parentheses. That's the root. But it also had a power of 2. What does 5 squared mean? 25, because it's 5 times 5. 5 times itself 2 times. Let's imagine for a second if we had done the power first. That would mean 125 squared. Do that on your calculator. 125 times 125. And look at that number for a second. And if I ask you, okay, let's take the third root of that. What times itself 3 times gives you that number? It's 20, obviously 25. But that would take a long time, right? You didn't already know what the answer was. So that's why we do the root first before the power. Okay, the power make the number way too big. It'll be hard to figure out the root. Okay, so try this one. 32 to the 2 place. Rewrite it as a radical with the root first, parentheses, and the power on the outside. Think about what the answer is. All I want you to do is to rewrite it. That's why we practice all this rewriting over here. I want you to rewrite it with a radical first. What's the root? The 2 or the 5? The 5. Right? So I'm going to write it. Think it all to heck this thing. 32 to the 5th root. Okay? That I said, so this is what I mean when I say do the root first. So that's the root. Doing the power second. Once you figure that out, you're going to square it. So, what is the 5th root of 32? 2, right? What times itself 5 times 32? 2 times 2 is 4, 8, 16, 32. So you do the root first, then you do the power. What is 2 squared? 4. Because it's 2 times itself, okay? So if you're stuck on the problem and you're just staring at it trying to get the answer, that's not how it has to go. Look at the other stuff we did, take it step by step, do the root first, and don't worry about, okay, well, that's fine, she's going to do the root first, but then what? Don't worry about the then what. Do it one step at a time. Figure out the root first. Then do your power. Try this one. (16 to the 3/4). I said write it with the root and the power on the outside. You could even just sort of do the root first and think about the power later. Like you could say, okay, let me do the root first. The 4th root of 16 means 2 because it's not 16 divided by 4, right? What times itself 4 times gives you 16? That's why it's 2, because if you had 4 2s and you multiplied them, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 2. And then you do the power. The power is 3. What's your weight list?
2 times 2.
No, these just both happen to be 2, but it's not going to always be. Did you have a question?
Yeah.
What?
Cocaine.
Oh, I was saying if I had 4 2's and I multiplied them. 2 times 2 is 4, times 2 is 8, times 2 is 16. Maureen, did you have a question? Here's the last one. 25 to the 1/2. To the 1/2. Root first, what's the root? 2. Power second. Power is 1. What is the square root of 25? What times itself twice is 25? 5. So you do the root first, the power second. What is 5 to the 1? 5. The last thing I'd like you to do is just take a second in your own words, okay, and explain why 9 to the 1/2 equals 3 is true. And that's the last thing I want you to do for your notes. The practice worksheet I'm about to give you, I would love for you to do it right now and go check your answers and let me know if you have a question. But I'm not actually picking it up until tomorrow. So you don't have to.